It's the stuff of nightmares. In June, as the world watched in horror, London's Grenfell Tower was devoured by flames. At the height of the blaze, parts of the building rained down near firefighters and bystanders. To many in the building industry, even here in Australia, it was clear straight away what was falling. It was aluminium cladding that had been made with a highly flammable polyethylene or PE core. Did you know what was on the building when you saw those pictures?
Absolutely.
What did you think?
Absolutely, it's PE.
Why did you think that?
Because of the way that the flames spread, the way that the panels were falling off the wall. Just because with PE goes up the building and down the building. The droplets spread the flame, and I knew exactly what it was, absolutely. And anybody in the industry that would know exactly what it was.
The fire began from an electrical fault in a fridge in a fourth-floor apartment. The flames leapt out a window, caught the cladding outside, then raced round the building and up 20 floors to the 24th within 15 minutes. So how combustible is this stuff?
A kilogram of polyethylene will release the same amount of energy as a kilogram of petrol. And it gets worse than that because polyethylene is denser than petrol too. So that's about, a kilogram of polyethylene is like about 1.5 litres of petrol.
And so how many kilograms of polyethylene might there be on the side of a building?
If you look at a 1 metre by 1 metre square section, that will have about 3 kilograms, the equivalent to about 5 litres of petrol.
Grenfell Tower was a catastrophe. Polyethylene cladding, flammable insulation, poor maintenance, a lack of sprinklers, and bad advice not to evacuate. The inferno left more than 80 people dead. The final toll still isn't known. The Grenfell fire shocked UK authorities, but for some it was a reminder of what almost happened here.
Yeah, the flashbacks happened. You sort of thought about what could have been at the Crosse, but it's an absolute tragedy, just a waste of life, really.
2.5 years before the Grenfell fire, 450 people in a Melbourne high-rise had a narrow escape. The Crosse Fire began just after 2 a.m. on a Tuesday morning in a redeveloped industrial area called Docklands. Swim coach Peter Howes was asleep on the 16th floor.
Well, I woke up thinking my alarm was going off, gonna head to work, and I got up quickly, turned the lights on. I looked up into the ceiling and I could see about 30 centimeters of smoke. So it was my smoke alarm that was going off.
The fire started on an 8th floor balcony.
Emergency services, what is the address that you need the fire brigade to go to?
Flat is 805,
Yep.
and the address is 673 Latrobe Street.
In what suburb or town?
It's Docklands.
The Docklands, 802/673 Latrobe Street, Docklands.
So there's just a fire in the balcony. I don't know how it started.
And
I
is
don't
it
know.
your apartment?
It's really big though. It's
Is it your
really,
apartment?
really big.
The fire brigade will be there soon, bye.
The first crews arrived within 5 minutes. They were expecting a fire in one apartment. They couldn't believe what they saw.
This was outside the building. It was burning on 5 or 10 floors. This was completely outside of anything that we were prepared for or expecting. It was actually a moment of absolute silence in the truck.
Tim Erickson was one of the first responders.
We have a fire in a multi-storey apartment, multi-storey building. Fire is on the 3rd floor, extending up to the 10th floor, going along the balconies. We have a huge amount of smoke and fire on the building. We have multiple people inside the building.
Well, the first thing we needed to do was to look out for the people that were there and get them out of that building.
Firefighters had to check more than 200 apartments.
They banged on the door, actually.
Yeah, twice, yeah.
That's what kind of really woke us up to, oh, wow, we better check this out.
Brooking and Lauren Stapleton were on the 3rd floor.
You could smell the smoke, you knew there was a fire. It was evident there was a fire as well. And the firemen were, they were, come on guys, you've got to get down there quickly.
It was burning really quickly and really fiercely. I spent a couple of minutes outside at the front, just marshalling the crews and getting them organised. But those couple of minutes I spent at the front, you could see it spreading upwards.
Within minutes, the flames had reached the 21st floor, the top of the building. Around 450 people were evacuated.
When we turned around and saw the fire up the side of the building, it was a bit shocking, wasn't it? We couldn't believe it. We didn't realise it had gone so high at this point. It was scary, actually.
The Crosse Fire astonished the fire brigade's most senior firefighters.
Our whole history of, over 100 years, 125 years, and the way buildings are constructed, we've never seen anything like it before. So you have multiple seats of fire over multiple levels all at the same time. And what that does is actually challenges the way you fight a fire.
The fire didn't only spread upward.
We did have a case here where, even though the fire started on the 8th floor, burning chunks fell down below to the 6th floor, and the fire ignited on the 6th and connected up with the 8th.
Incredibly, thanks to good luck and a good sprinkler system, there were only a few minor injuries. The fire brigade says there could easily have been fatalities.
A scenario such as La Crosse, if it wasn't brought under control in a pretty quick amount of time, it could claim hundreds of lives. There's no doubt about that. And we did say it was a fire that's unexpected, unprecedented. We responded really, really well, and the building occupants themselves self-responded really, really well. So there was a lot of things happened to that particular fire that worked well for everybody.
We were really lucky with the weather conditions on the night. If we'd had flaming lumps of molten aluminium be pushed by the wind to adjoining apartment balconies, it would have gone up another section. So, and that's what we've seen from other fire, looking at other fires around the world, that's pretty similar behaviour.
So this is the panelling that we're talking about here, is it? This cladding on the veranda?
Yeah, at the end of the balcony here.
The Metropolitan Fire Brigade launched a major investigation. It was coordinated by Commander Mark Carter. He showed us how the fire started on an 8th floor balcony. A French traveller on a working holiday came home late, had a cigarette, and thought he put it out in a plastic container.
We had outdoor furniture, we had lots of combustible items.
The fire brigade made a graphic reconstruction.
So we had, in this case, a table and chairs and lots of things around it. As we know from the fire investigation, there was a plastic yogurt container that was being used for cigarette butts. That started a fire onto the timber furniture. Fire got in behind the air conditioning unit, and then the panel ignited. And with the ignition of the panel, we had flames shooting up the side. So the fire actually spread from one level to another and continued on up the building.
This shows how the fire spread up the building from balcony to balcony.
What's really striking about it was actually the fire progression. It progressed, up to level 21 in less than 8 minutes. Nobody in this, in the country's really seen anything like that before. And the vertical fire spread for that particular fire was unprecedented. In my career, I've never seen anything like it.
Cladding, made from 2 sheets of aluminium sandwiched around a core, ran right up the building.
Our first reaction was, how the hell has this happened? You know, how have we got a modern building that, you know, and we know what the construction code says, that you shouldn't have a combustible product on the outside of a building of this type. So how has this been allowed to happen?
The fire brigades sent a sample of the cladding to the CSIRO for testing.
We're pretty confident of the results we would get, but we were nonetheless surprised when CSIRO reported back to us and said that they had to cease the test because they thought they were going to damage their equipment.
The fire brigade was even more surprised to be told that the core of the cladding was made of 100% polyethylene, a highly combustible plastic.
The report came back and said that the cladding type used was a combustible piece of cladding, and in effect doesn't comply with the regulations for a building of that size.
So how did it get to be there?
Well, that's the million-dollar question.
So how many other buildings do you think would have similar types of cladding?
Well, I can't answer that. I reckon it's unquantifiable.
Unquantifiable?
Yeah.
Does that mean thousands?
Well, it might mean more than thousands.
Aluminium cladding has been spreading all over Australia for more than 3 decades. Darren Hodder spent 20 years selling and installing it in Brisbane. He says from the first time he showed it to architects, they loved it.
They liked it because typically we'd had solid aluminium in the market, which was harder to fabricate. It's not as straight or as flat. The paint finish also is not as high quality as well. And that's what the composite panel delivers. It's an unmatched quality product in that regard.
Most of the cladding Darren Hodder sold was made in Japan by Mitsubishi. In the beginning, no one questioned the fact it was made with polyethylene.
What did you know about that at the time?
All I knew about it was good for manufacturing. It was lightweight, and yes, no other issues back then.
All through the 1990s, Darren Hodder sold tens of thousands of square metres of polyethylene cladding every year for buildings like this one in downtown Brisbane. But then, around the year 2000, Mitsubishi sounded a warning that polyethylene was flammable.
We had Hiroshi Tanaka, the big boss of Mitsubishi, very respected man globally, and he came out to Australia, and he had known there's some issues with polyethylene. We had no idea at the time, and he just said, no more polyethylene.
Stephen Geddes had been selling Mitsubishi's polyethylene cladding in Sydney. He remembers a Mitsubishi engineer telling him that polyethylene, a byproduct of the petrochemical industry, was basically a fuel.
I remember some time ago, back early 2000s, they had an older engineer that worked there who said that a building that had something like 3,000 square metres of panel on contained about 3,500 litres of petrol. So it's quite scary when you think about it.
By then, Mitsubishi had developed a new fire-resistant, or FR, cladding. It still contained polyethylene, but much less. FR was less combustible, but more expensive. Geddes and Hodder both started selling it.
At the time, we were, as much as, $10, $11 a square metre, more expensive. So it was a massive risk on, the company's behalf to do that. And we did lose sales. Absolutely, we did lose sales because of it.
But there were already hundreds of thousands of square metres of PE cladding on Australian buildings. and most of it is still there.
So up until 2000, when your company switched over to FR cladding, how much PE cladding would there have been going up in Australia?
Tens of thousands of square metres. There would be, if not hundreds of thousands of square metres.
And most of that is still there?
Yes.
Other companies continued selling PE. Mitsubishi's biggest cladding competitor was called Alucobond. It was made in Germany with polyethylene. Alucobond PE still graces high-end developments from Sydney to Perth. In 2007, the new Australian supplier of Alucobond invited Darren Hodder to the manufacturer's headquarters in Germany. Hodder was shocked to be told that although the Germans had developed a fire-resistant cladding, polyethylene cladding was still being sold in Australia.
We sat down at the boardroom table and I'd said to the head German engineer there, I said, well, what are you using through Europe? And he said, well, the Alucobond Plus, Darren, and the next product up from that. So I then turned to the two people that had taken me there and said to them, why aren't you bringing it into Australia? And their response was, we don't have to, and it's cheaper to stay with polyethylene.
Four Corners asked the supplier of Alucobond for an interview, but they declined. They did not recall the comment allegedly made in the meeting in Germany. As building boomed, even more PE cladding began flooding in from Asia. It was modern and shiny, quick and easy to build with, and most of all, it was cheap. By the late 2000s, PE cladding was on the march.
What was the state of knowledge in the market by then about polyethylene?
That it was highly flammable.
The problem was cladding had started out as just a decorative attachment. Now it was being used as the main part of walls. So did it really comply with the building code? Though everyone was using it, no one really knew. In 2010, the ACT Fire Brigade tried to come up with an answer. It called an industry meeting, but no one was sure. The Australian Building Codes Board couldn't say either.
There was a lot of talk about what needed to be done, what could be done, but how many people had to be involved and the time that it would take for it to go through. So it really just got brushed under the carpet.
Since La Crosse, a Senate committee has been looking into building products. In July, after the Grenfell Fire, the senators asked the company that sells Alucobond whether PE cladding should be banned in Australia.
The question is, why should we allow it into the country? I'm old-fashioned. I think non-combustible, it shouldn't catch fire, it shouldn't be a fire hazard.
Yep.
So what standard is non-combustible then?
The code is actually, well, the standard is AS 1530 Part 1, and there is no such thing as a panel that passes AS 1530 Part 1 as the product would be supplied.
What do you mean, no such thing? I mean, we have a standard, but no one complies with it.
Correct.
No one can comply with the standard. Just say, can you explain it to me? So there's a standard for non-combustible material, AS
1530 Part 1.
AS 1530 Part 1.
Correct.
But no buildings, no one actually complies with that at the moment.
As the material would be supplied. So if you supplied a material,
yeah,
the product would not pass that test.
Sorry, I'm being a bit slow here. What are you saying? Yeah. You provide a material. So there's a standard that we can't comply with?
Correct.
Correct. On what, but why can't it be complied with?
Because the actual test itself is not intended for these types of products, for one.
So we have a standard that can't be complied with?
Yes.
It's not much of a standard then, is it?
No.
Okay, this is doing my head in. Look, it's like yes, Minister, now, but this could end up as a coronial inquest, because if there is a fire because of cladding and there are multiple lives lost, then no doubt we'll have a Royal Commission, no doubt we'll have coronial inquests, and people will be asking, why weren't we warned about this? Well, the fact is the warnings have been out there for years, and this inquiry is basically saying there are no excuses not to act.
Four Corners asked the CSIRO to show us the building code's test for combustibility. Alex Webb is a CSIRO fire engineer.
So what have we got here, Alex?
So we have 3 samples of the core materials from the aluminium composite panels.
Yep.
100% polyethylene core. This is what's known as an FR with some mineral filler or fire retardant. And this is a much higher proportion with only a small proportion of polyethylene.
And what are you going to do with them?
This is the Australian standard 1530 Part 1 apparatus. So this is quite a small but ferocious test.
The first sample is 100% polyethylene, the material used in the core of PE cladding.
So the furnace is held at 750 degrees Celsius and very stable temperature. It takes quite a while to warm up. So what we're looking for is any flaming that occurs, and also we log the temperatures within the sample on the side, and if that temperature rises more than 50 degrees, that's also one of the other criteria. So we have to run the test for 30 minutes and be able to measure the temperature from the end to the highest peak as well.
The combustibility test is supposed to run for half an hour, but the PE failed in minutes.
One sample flames more than 5 seconds, that's combustible. So that ignited very early and flamed substantially, and we have to take the sample out, as you saw. If we leave it in too long, all the material melts to the bottom, or we damage the equipment.
The fire-resistant cladding only did a little better.
So the next one, it had some filler in it, some fire retardant, so mineral filler.
About 70%, you said?
Approximately, yes. But that's still got 30% polyethylene, so it performs very similarly in this test. Still flames, still gets a temperature rise, but it does it a bit slower.
So technically combustible?
Deemed as combustible.
Even the most fire-resistant cladding, with only a very small amount of PE, is still combustible.
And then the final one, tell me about that one.
That's still polyethylene, but it has even more filler. That as well would be deemed combustible because that one still flamed. So this test method's really good because it's quite cheap, reasonably quick, has a high bar to pass, so we know that the results are good and we're going to end up with a safe product.
The problem is, it's a test of components, and it wasn't designed for products like cladding. There are plans to introduce a much bigger, full-scale wall test, like one already used in the US, next year. But it's much harder to do and much more expensive.
It's quite a bit different test method, but that it can be used if you need to get compliance for a whole wall system, which includes the cladding, the insulation and the structure.
There's products that come into the market that don't meet the requirements of Australian standards. We know that, and we've seen that as a result of Crosse. So we need to look at the way we accredit products and the way we import products.
Should they be banned from import?
Well, it's not about them being banned because some of them meet appropriate applications. You can get a piece of cladding that you can use on your own home, but you can't use it on a multi-storey building.
Our building code also allows the products to be used if an engineer has done a full assessment that says it's safe to use it in this particular way in this particular building.
Jonathan Barnett is a fire engineer, yet it was only after the Crosse Fire that he checked out the cladding on his own building, where he bought off the plan 4 years ago. It's PE, It stretches right up to the roof and it will have to go. But Barnett's not panicking.
Well, I wouldn't live here if I wasn't comfortable. I do this for a living. I mean, I worry about fire engineering. The building is safe to occupy. Do we have to fix the cladding? Absolutely.
Other fire engineers are less sanguine.
My personal opinion? No. No, I don't think there's... I don't think that there's a place for polyethylene cladding on buildings at all.
Tony Enright advised on fire safety for the new Royal Adelaide Hospital, which opens this week. Enright recommended one of the highest grades of fire-resistant cladding available, and one of the most expensive.
At the time, we were saying, do you want to wrap your hospital in plastic? And after a couple of years, we changed that to, do you want to wrap it into petrol?
Fires like this at an apartment block in northern France show how polyethylene cladding can inflame and fuel the fire. This one left one resident dead. A couple of years later, combustible cladding caught fire at one of the tallest residential buildings in the world, the 86-storey and unfortunately named Torch Tower in Dubai. But polyethylene isn't the only dangerous product we're putting on our buildings. Now polystyrene is springing up too.
The product we're talking about is the styrene foam that's used in packaging and so on. If it burns, it'll melt. It'll melt like a marshmallow. There's a lot of it. There's an enormous amount of it now because it's a cheap means of construction. And when it's rendered with an acrylic render over it, it looks like concrete for all intentional purposes. Most people would think and believe that they've got a concrete building. Up on the building there...
Phil Dwyer is the president of the Builders Collective. He showed us this polystyrene-clad building in Melbourne. Earlier this year, a fire broke out in an air conditioner on a balcony.
It was fortunate that the fire happened at a time no one was around, no one was injured. The damage to the building was pretty contained by the sprinkler system. But to us, it was a really good example of other forms of cladding that are out there getting widely used in the industry.
In Melbourne, the fire brigade fears that in future, polystyrene could be even more of a risk than PE because it's used a lot on low-rise buildings, and they don't have to have sprinklers.
I think you've only got to go for a drive out in the suburbs and see the growth in the 3 to 8 storey building apartment sector to have some level of concern.
This 3-storey block has no sprinklers. In March, a discarded cigarette butt set alight polystyrene cladding on the balcony. A resident was badly burned, trying to put out the fire. The burnt balcony was eventually repaired with new polystyrene.
There's a whole debate going on around whether it's compliant or not compliant. The issue we want to bring to everyone's attention is it burns.
This Melbourne building had to have fire screens added for protection. A building this high shouldn't strictly have polystyrene cladding, but it does. A fire engineer and a certifier both ticked off that it was being used safely.
This particular building was subject to a fire engineering analysis. A fire engineer has said that that's okay, and a certifier has checked that and approved it.
What do you think of it? Is it okay?
Absolutely not.
There's a view that deregulation and privatisation in the building industry have gone too far.
We decided that privatisation was the best thing in the world. So we privatised everything, including building surveyors, and also we changed regulation, dropped red tape and so on. And we've dropped far too much red tape. But maybe better still, we haven't enforced the regulations that are there.
And there's a view that cost-cutting too often wins out over caution.
We've got parties who are incentivised by taking risks, and then we've got other parties who bear the consequences of those risks if they go wrong. So we have, if you will, a builder, a certifier and a fire engineer who are incentivised to reduce cost. The builder, because it's going straight onto their bottom line. The certifier, because they want repeat work from the builder. The fire engineer, because they want repeat work from the certifier and the builder. And so they're all taking risks. It's the building owners who bear those risks.
A few weeks ago, the Torch Tower in Dubai caught fire again, for the second time in 2 years. Everyone was evacuated, but it showed that where cladding is risky, something has to be done about it. The same applies in Australia.
I did think more might have happened, and I think, Crosse for us was unique because it was non-compliant or non-conforming product on a building. It identified a bit of a regulatory failure. So, we put that on the table and not a lot had been done. And since Grenfell, the Victorian government has established the Victorian Cladding Task Force, which has a scope to look into all this particular stuff, look at a methodology of, fixing buildings retrospectively and developing new legislation moving forward. So, it's taken Grenfell to give us a bit of a kickstart, which is, from our perspective, is it's not too late, but it's been a little bit slow, the reaction.
Nearly 3 years on, most of the combustible cladding is still on the La Crosse building, with a battle raging over who should pay the $8 million needed to replace it. It's not surprising that the question of who should pay to fix the problem here soon got bogged down in expensive litigation. The owners want the builder to pay, but the builder says, not my fault. And if it is, what about the architect who designed the building? Or the fire engineer who signed off on it? Or the surveyor who certified it was fit to live in? And then there's the occupier of the apartment who let too many people live in it. And don't forget the overseas traveller who came home late after a double shift, had a cigarette and thought he put it out in a plastic container on the balcony.
This is an absolute legal minefield as to who's responsible. The potential litigation, the insurance claims, the finger pointing between various authorities and contractors is enormous.
My view on this is that, if I had bought the building myself and I was living in La Crosse and I was faced with this, I wouldn't be very happy either. I'd be looking for someone else to pay.
There are also costs to the public and fire brigades.
A building like La Crosse, which would normally have a 2 appliance response, would now have 6. And one of those will be an aerial appliance, a ladder platform with 26 metres reach and able to affect rescues from balconies and all those sorts of things. The fire itself, because it generates a lot of heat, the panels actually delaminate. And when they delaminate, they fall off the building and you've got a whole lot of airborne parts of the building raining down. This happened at La Crosse, it's happened at every one of the other fires that's happened around the world. So what that does, it's a whole new danger that the firefighters are faced with and even the occupants coming out of the buildings.
The fire brigade says the solution has to come at the outset.
It's my view, and I've held this view, for 20 odd years in fire safety, that you've got to get it right at the front end. If you're chasing your tail at the back end, something's gone wrong in between.
You've got this whole chain of people involved in building design, construction, certification, supply of materials. You can't tell me, for example, that if this product, by all reports, has been used widely in the industry for 10 to 30 years, that major suppliers of this product in Australia didn't know where this product was going to end up. To me, I've heard that argument and I don't buy it, to be honest.
Four Corners asked 3 major Australian cladding suppliers to identify buildings with PE cladding. None of them did. Suppliers say it's up to certifiers like Robert Marinelli to sign off on buildings. But Marinelli says certifiers are only required to make a limited number of site visits, and no one wants to pay them to come more often.
That's it. Ready to go. Well, we can't be on site all the time. We can't be covering every part of the building or every screw or every component. That expectation's too high. So we rely on the subcontractors, the designers in the process to provide us affirmation or certification of their products and how they're installed, because we can't be there all the time.
And why is that a problem?
Well, you're basically leaving that accountability to the people that are installing.
So we've been running all the standard panels for level 7 now?
But installers like Seamus Marnell say that in most states, no one needs a licence to install cladding.
Anyone can do it.
So what does that mean? I mean, is that what happens in practice?
Yeah, there is people out there that would have absolutely no idea what they're doing, and they're installing it incorrectly, and they're the people we compete against every day.
And why does that happen?
Price, cost, I guess.
People that actually put the material, they've got to have...
The Senate inquiry has now been looking at problems with building products for more than 2 years.
And it's what struck us on this committee, I think I speak for other senators here, is that no one is held responsible. Everyone has someone else to point the finger at. The product of this deregulation, this self-accreditation, this process of abrogation of responsibility is that no one is responsible.
The committee's heard evidence of universal failure, confusion in the building code, a lack of enforcement, and no national licensing.
I have more consumer protection buying a refrigerator than a $1.5 million apartment. How can that happen?
Lawyer Stephen Goddard, who represents strata bodies, says it's time for the law to impose responsibility and protect apartment owners.
Gentlemen, you have no option to kick this down the road another 5 years. There has to be a level of accountability. I know that in the Docklands area there are many buildings in the same position as La Crosse. The same is the case in Sydney and probably on the Gold Coast.
Audits are now underway across most of Australia, but it's hard to know what will come of them. An audit in Melbourne after La Crosse found cladding on 170 buildings in the CBD alone, and that didn't include office blocks.
The reality is we know we've got a lot of office and retail complexes out there that it's been widely used on. So I think we're just at first base, really. There's a lot of work yet to be done.
The New South Wales government has recently sent out more than 1,000 letters advising building owners to get fire checks on their cladding. But the next step is unclear.
Well, let's not get ahead of ourselves. We're talking about hypotheticals. We don't know that the cladding on buildings in this state that's been identified is unsafe. And if it is unsafe, we don't know whether or not there are appropriate systems and processes that will ensure that that cladding is safe.
The Queensland government is taking the threat of risky cladding seriously. It's identified that Princess Alexandra Hospital, built in the late 90s, is covered in combustible cladding. It's put on extra safety measures and sent some of the cladding off for full wall testing. Queensland is the first state to introduce legislation putting responsibility on everyone involved in construction and signing off on a building.
But what we need to do is make sure that the system that keeps everybody safe is made more robust again. And it's clear to me that the innovation in building products like cladding on the outside of a building has significantly undermined the strength of the building integrity system, and that needs to be restored.
We know there are millions of square metres of combustible cladding in Australia, but we don't know where most of it is or what to do about it. It will be a big job, and combustible cladding is just one symptom of a much more systemic failure in the whole building industry.
We've got all these sort of checks and balances that have somewhere along the line have been missed. What we've got is a legacy of a lot of buildings that you've got to question their safety going forward in the future, and I think that's really unfortunate.
We need enforcement. You can stack all the regulations you like on top of one another. If you don't enforce them, they're not worth anything.
And whose job should that be?
That should be our governments, that we pay an enormous amount of money to look after this for us, and they have failed us completely.